Hi, it's Mrs. Garple, and we are going to take a look at scatter plots and lines of fit again in this particular lesson. And what's going to be different with this lesson is we are going to be writing an equation using 2 points on the line. And once we have that equation, we are going to be using that equation to make a prediction. So in Unit 1, we would make a scatter plot of the data. We would model the data with a line. We would draw that line, but then we used the line itself to make a prediction. This time, we're going to write an equation using the equation of that line. Now, when you write the equation of the line, the 2 points that you use don't have to actually be data points. They are just points that are on the line of fit itself. So let's take a look at our first example. Here we have a table that shows the salaries, Y, in thousands of dollars. So I'm going to make a note here that Y is salaries, of 5 architects and the numbers X of years of experience. So X is years. Write an equation that models the salaries as a function of the number of years of experience. When you see the phrase function of the number of years of experience, that means that that's your input. That's your X, even though they already told us that X is years. So before we do anything else, let's make a scatter plot of this information. So we know that X is years of experience, so I'm going to label the graph years of experience, and you should always label your graphs so that someone else looking at your scatter plot knows what you're talking about. And then we have salaries, and I'm writing sideways here, so bear with me. And I'm going to make a note that this is in thousands. And because I'm told it's in thousands, I don't have to actually write this as 50,000. I can just write 50, 55, 56, 60, 62. So I can, for my X scale, my years of experience, I can start at 0 and just increase it by 1. 1, 2, 3, 4, 5. For my Y-axis, it appears I need to have a break. Now it's important that you show that break in the scale. And I'm going to start at 50. And I believe it would be okay to go by twos. So 50, 52, 54, 56, 58, 60, 62, 64, and that's more than enough. Now we can plot our points. So we have 1 is at 50, 2 is at 55, 3 is at 56, 4 is at 60, and 5 is at 62. And as we look at this data, we can see that there's a positive correlation. As the number of years increases, the salary increases. So we can draw a line of fit to fit this data. And keep in mind, when you draw a line of fit, you want it to divide the points evenly, meaning you want it to divide it so that the points are approximately split in half, so that half the points are on one side of the line, half the points are on the other side, and the line is following the trend of the data. So I'm going to start with one line here. We'll see how it looks. And right now it looks like I have more points under my line than I have above my line, so I need to do some adjusting. And this is where clear rulers really help us. And I do have my line going through two of the points. Two of them are slightly off of the line on the right side. One is off the side on the other side, and it's going through two. So I'm going to go ahead and use this as my line of fit for the data. So now I'm going to write my equation that models the salaries. And since I do have it going through two of the data points, but another thing I'm going to point out is those two data points are actual grid points as well on my line. We have one at 150 and we have one at 460. So when we find our slope, so these are the points we're using, 150, 460. Remember, slope is change in y over change in x. So I'm going to do 60 minus 50, 4 minus 1. So our slope is going to be 10 over 3, or approximately 3.3 when we round it to a decimal. And the reason I went ahead and rounded it is that this is an application. So y is the salary in thousands and x is the years. So we have this interpret the slope portion of our directions. So I can say the slope increases $3,300 per year. That takes care of interpreting the slope. Excuse me. Now let's find the equation of our line. All we need to do is pick one of the points. We can't just use y equals mx plus b because I don't know what the y-intercept is for certain. So we're going to use that point slope form, that y minus y1 equals m times x minus x1. So I'm going to use the point 150 as my point in this equation. So we're going to have y minus, the y value is 50, equals, our slope is approximately 3.3, times x minus, the x value of that point is 1. So this is the equation of our line. Our directions also said interpret the y-intercept of the line of fit. Well, if we want to interpret the y-intercept, that means we need to find the value when x is 0. Because when x is 0 is when we have the y-intercept. So we're going to take this equation, and to find the y-intercept, let's plug in 0 for x, Oops, I don't want that set of parentheses yet. Plug in 0 for x, and simplify to find y. So 0 minus 1 is negative 1. So we'll have 3.3 times negative 1, which is going to turn into y minus 50 equals negative 3.3. Now I know we haven't done a whole lot of solving, but if you remember anything from any of your pre-algebra topics, if I want to get the y by itself, I need to undo the minus 50. So I'm going to add 50 to my negative 3.3. So that my y value, which is going to become my y-intercept, is going to be 46.7. And the y-intercept then, and I'm going to use a different color to explain this, the y-intercept means the starting salary for an architect is $46.7 thousand. So we're able to get a little bit more precise in some values when we use the equation of a line of fit. In the next example, we have data comparing monthly income with a monthly car payment. As you can see, the scale is already showing a break. A line of fit has already been drawn in, and we are tasked with writing an equation that models the monthly car payment, and then to use that equation to predict the car payment for a monthly income of $3,000. As you can see, our graph doesn't go out to $3,000 for an income. So this is when we would use our line of fit to make a prediction. So let's start with writing the equation. First thing you want to do is find two grid points that your line goes through, or two known points. So I'm looking at the graph and I see that we have one point here at 1700, and this would be, we're increasing by 30, so this would be 15. So if I write in that number there, this is going to be 335. And then I have another grid point. If I follow my line from there, I have another one right here. So at 1900, 380. So let's find our slope. Remember, slope is change in y over change in x. So my largest y value is 380 minus 335 over, at 380 the income was 1900 minus an income of 1700. So our car payment increases $45 for every $200. Now let's convert that to a decimal. Grab my calculator here and I divide 45 by 200, and I get 22.5 cents. So 0.225 is what it's increasing for every dollar increase in monthly income. Now let's write our equation. I'm going to go ahead and use the 335 to write my equation. So just a reminder, that's y minus y1 equals m times x minus x1. So y minus the y value of this point is 335. We found the slope to be 0.225. And the x value when the payment is 335 is 1,700. So now we can go to part 2 and use that equation to make a prediction. Because x is the monthly income, I can write y minus 335 equals 0.225 times, replace x with 3,000, because that's what we're making the prediction for, minus 1,700. And now we can simplify things on the right-hand side. So we have y minus 335 equals 0.225 times 3,000 minus 1,700 is 1,300. We want to multiply that times 0.225, and that's 292.5. So now, to find out what that monthly car payment is going to be, we need to get the y by itself. So we need to undo the minus 335 and add the 335 to get the monthly car payment. And because it's a monthly car payment, I need a dollar sign on my answer. And that means my monthly car payment is going to be $627.50. And that's how we can use the equation to make a prediction, especially when our graph doesn't allow for us to make a prediction further out.